All right, everyone, let's work some more with exponential functions because everyone loves exponential functions, right? Okay, let's just look to our left here and remind ourselves the general form of an exponential function. That's going to be f of x equals a times b to the x power, where remember a is equal to the initial value of the relationship and b is equal to the common ratio. All right, so let's get some practice writing these out, just given basic information. We'll start off pretty simply. All right, let's say we have an exponential. We have an function, exponential function whose initial value is, let's say, +5, and whose common ratio is, let's say, 7, right? An exponential function whose initial value is +5 and whose common ratio is +7, right? Well, this is pretty easy to write. We're just going to plug it right on into our formula, right? F of x equals a times bx, sorry, a times b to the x power, or the initial value times the common ratio to the x power, right? Just that simple. Let's do one more simple example just in this exact same form here, right? Whoops, let me get rid of that. There we go. Okay, let's get rid of, wow, nothing's working for me right now. There we have it. Okay, let's get rid of these guys. And let's say our initial value was, I don't know, 13. Let's say our initial value is 13. There we have it. And let's say the common ratio is 1/2, right? We can have a common ratio less than 1. Let me try to make a better looking 1/2 than that if possible. 1/2. All right. So let me get rid of our last answer. Sometimes, there we go. Sometimes this certain command does not work very well. I don't know why, but there we have it. Whoops, it's not what I want. Okay, there we go. All right, initial value is 13. Common ratio is 1/2. That's as easy as can be, right? F of x equals 13 times 1/2, right? The x power. That's not so bad. Of course, we want to know we could also write this as y equals 13 times 1/2 to the x power, right? Because remember, in linear functions, sometimes we wrote f of x equals mx plus b. Sometimes we wrote y equals mx plus b, right? They just mean the same thing. And remember why they mean the same thing, right? Because we're talking about functions, and where do we graph the value of the output of a function? We graph it on the y-axis, right? So if we're graphing a function, of course, the value of f of x is equal to the value graphed on the y-axis, right? Okay, so speaking of the y-axis, speaking of that good old y-axis, let's try to answer a question in this form. Let's try to answer a question in this form, okay? Let's say the graph, of an exponential function has a y-intercept at the point, as a y-intercept at the point 0, comma, say 0, comma 1/3, okay? 0, comma 1/3. Its common ratio, let's say its ratio, same thing, common ratio. Its ratio is, let's say, 3, okay? Its ratio is 3. And what if we wanted to write this function, okay? Well, we're outright told what its common ratio is. We're outright told its common ratio is 3, so we know that b is equal to +3, right? But how in the world do we find a? how in the world do we find a? Well, remember what a is, right? A is the initial value. And remember, the initial value of a function occurs at the y-intercept, right? Remember when we had our linear functions, y equals mx plus b, where b stood for the y-intercept of the line we graphed. It also stood for the initial value of the function we were graphing, right? So similarly, the initial value of an exponential function or an exponential relationship is the value at the y-intercept of the graph, right? So if we have a y-intercept at x equals 0 and y equals 1/3, that means, of course, that our, get rid of this question mark because we know that that means the initial value is 1/3, okay? So therefore we know that that this function, the formula, we can write it as 1/3 times 3 to the x power, right? F of x equals 1/3 times 3 to the x power. That is our equation or formula for this function. All right, everyone, let's look at one more example, okay? So the graph of an exponential function has a y-intercept at the point 0, 100. The common ratio of this function is positive 1/5 or 1/5. Write this function in y equals a times b to the x power form, right? So remember, this is the same thing as f of x equals a times b to the x power, right? So that's just the general form of our exponential function. Okay, so we need to find what a is, right? We need to find what a is, and we need to find what b is in order to write out the formula of this particular function, right? Well, b's easy, right? We're given b outright. We're given that the common ratio of this function is positive 1/5, right? So we can outright say that b is equal to 1/5. How do we find a? Remember that a is the initial value, right? That's the value at which the relationship starts, is sort of a way you can think of it, right? Anyway, a is the common value, and it is the value of the y-intercept, right? It's the value where it's the y value at the y-intercept, right? It's just like b in our y equals mx plus b linear functions, right? And what is the value of the y-intercept? It's positive 100, right? Positive 100, because when x equals 0, y equals 100, according to the information we were given right here about the y-intercept, right? So we know a is 100, b is positive 1/5. So we can say that y equals 100 times 1/5 to the x power, right? And in general, since a is the initial value, a is always going to be the value of the y-intercept, right? So for any exponential function, if you have it in the form f of x equals a times b to the x power, it's always going to be the case that the y-intercept is going to occur at the point 0, comma, a.